Now here the question is, a variable straight line through this point A is drawn to cut the circles at points B and C. So we have this circle x square plus y square equals to 1, and then we have this point minus 1 comma 1 which lies outside this circle. So this is your point A, minus 1 comma 1, and it intersects this circle at B and C, and there is any general point P on this line which is suppose at a distance R from A, and also let distance of B from A is R1 and distance of C from A is R2. Now we can write parametric equation of this line passing through A. So this equation will be x plus 1 upon cos theta equals y minus 1 upon sin theta, and will be equal to R. So coordinate of any general point P will be minus 1 plus R cos theta and 1 plus R sin theta. Now we need these points B and C which lie on the circle. So this general point, it will lie on this circle. So from here we can write minus 1 plus R cos theta square plus 1 plus R sin theta whole square, it is equal to 1. Then we square it, we get 1 plus, now R square cos square theta plus R square sin square theta will be 1, and then we'll have plus 2R, and here it will be minus cos theta plus sin theta, and it is equal to 1, and here we'll have one more plus 1. So this plus 1 and plus 1 will cancel. So basically we'll get a quadratic equation in R, and that will be given by R square plus 2 sin theta minus cos theta R plus 1 equals 0. Now this equation will have two real roots, R1 and R2. Now basically R1 into R2 will be 1, and R1 plus R2 will be 2 cos theta minus sin theta. Now we'll come to P in the context of this question, AB, AP and AC. So suppose we have this point P whose distance from A is R3. So now we can write coordinate of this point P as minus 1 plus R3 cos theta and 1 plus R3 sin theta, and we have to find locus of this point P. So since it is a locus problem, we'll take this point as alpha beta. So this point is alpha, this point is beta. So we'll get R3 cos theta is alpha plus 1 and R3 sin theta is beta minus 1. Now we can start solving the question. Now this first part is, we have to find locus of P if AB, AP and AC, they are in AP. That means R1, R3 and R2, they are in AP. Now basically R3 is R1 plus R2 by 2. Now R1 plus R2 we have already worked out. This R1 plus R2 is 2 cos theta minus sin theta upon 2. Now this 2 and 2 will cancel. Now we'll multiply everything with R3, so we can write R3 square will be equal to R3 cos theta minus R3 sin theta. Now we can calculate R3 square by squaring and adding them. So it will be this R3 square, and we can write this as alpha plus 1 square plus beta minus 1 square. So it will be this alpha plus 1 square plus beta minus 1 square, and R3 cos theta, it is alpha plus what? Minus, and R3 sin theta is beta minus 1. Now we can write this as alpha square plus 2 alpha plus 1 plus beta square minus 2 beta plus 1, and there will be alpha plus 1 minus beta plus 1. Now plus 1 and plus 1 will cancel. So this required locus will be alpha square plus beta square, this plus alpha, and then minus beta equals 0. So locus of this point P will be a circle whose equation is x square plus y square plus x minus y equals 0. Now it says D be the minimum distance of origin from locus of P. So we have to find minimum distance of origin from this locus. Now as we can see, this circle, it passes through origin, so its minimum distance is simply 0. So this A, it matches with P. So A, it matches with P. Now second part is AB, AP and AC, they are in GP. So for part B we have AB, AP and AC, they are in GP, that is R1, R3, R2, they are in GP. Now that means R3 square equals R1 into R2, and we know that R1 into R2 is 1. So basically it will be this R3 square equals 1, and R3 square is this value. We'll get this equation as alpha plus 1 whole square plus beta minus 1 whole square, and it is equal to 1. Now basically it is a circle whose center is at minus 1, 1 and which touches both the axes. Now we have to find minimum distance from origin. Now distance of center from origin, it is root 2 and its radius is 1. So this minimum distance, it is root 2 minus 1. That means this B, it matches with S. So B, it is going to match with S. Now this C is AB, AP and AC, they are in HP. So we have this C where AB, AP and AC, they are in HP, or R1, R3, R2, they are in HP. Now here R3 is 2 R1 R2 upon R1 plus R2. Now this is R3, R1 into R2 is 1, and R1 plus R2 is 2 cos theta minus sin theta. Now here 2 and 2 will cancel, so we'll get this as R3 cos theta minus R3 sin theta, and it is equal to 1. Now R3 cos theta is alpha plus 1 and R3 sin theta is beta minus 1, and it is equal to 1. So this required locus will be alpha minus beta plus 1 equals 0. So locus of this point P will be this straight line x minus y plus 1 equals 0. Now perpendicular distance from origin will be equal to 1 by root 2. So this C, it matches with Q. C, it matches with Q. And then AB, AP by 2 and AC, they are in AP. It says for this D, AB, AP by 2 and AC, they are in AP. That means R1, R3 by 2 and R2, they are in AP, or R3 is simply R1 plus R2. Now this is R3 and this is 2 cos theta minus sin theta, or we can write R3 square equals 2 R3 cos theta minus R3 sin theta. Now R3 square is alpha plus 1 square and this is beta minus 1 square and this is 2 alpha plus 1 minus beta minus 1. Now this equation will be alpha square plus beta square plus 2 alpha minus 2 beta plus 2, and here will be this 2 alpha minus 2 beta plus 4. Now 2 alpha 2 beta will cancel, so this equation will be alpha square plus beta square equals to, or locus of this point P is now this circle, which is x square plus y square equals 2. Now in this case, distance from origin is basically its radius, which is root 2. So now d is root 2. That means this d, it matches with r. So this d, it matches with r. So answer to this question is P as QR.